Hello everybody. In this video I'll record KPIs and topics related to term 2. So let's get started and delve into these KPIs. Starting with topic key concept 12 that talks about energy. Here these are the only KPIs we need to focus on. First of all, you need to understand, I'll just remind you, what types of energy do we have. We can consider that we have several types of energy. One of them is thermal energy, or which represents heat energy. We have light energy, chemical energy, gravitational potential energy, and nuclear energy. So here mainly you need to understand that energy is able to be stored as kinetic energy. As long as we talk about kinetic energy, immediately you relate it to change of speed or when object is in motion. These are key words to help you to understand the idea of kinetic energy. Gravitational potential energy, it's mainly related to height. When object changes the height or the position, like in this scenario, as we can see here, this is a roller coaster. During the motion, speed changes, height or position of the object changes as well. So when speed changes, this means kinetic energy will be changed automatically, while when height or when the position changes, consequently potential energy changes as well. One more, which is chemical energy. So what is a chemical energy? It's a type of energy that can be stored in could be in fuel, gas, could be stored in fuel, could be stored in food, wood, or battery. So I'm just showing you these are keywords. Whenever any of these points will be mentioned, so automatically without even thinking you go to pick chemical energy. We have elastic energy, which is type of energy stored in springs, mainly rubber bands. The other point you need to understand, how are we able to apply the formula of gravitational potential energy? Mainly it depends on potential energy, mainly the equation mgh. M refers to mass, g for acceleration due to gravity, h for height. Measuring unit for energy is always joules. Mass is measured by kilogram. G mainly is always 9.81 or 10 meter per second squared. Finally, height is meter. We are able to calculate any of these based on what given we have and what requirements. So we can use this method, MGH, to make it easier for you. Now, starting with answering questions related to this concept. Which of the following types of energy is stored due to an object's motion? So this is our keyword. As we have mentioned earlier, you try to find keyword to help you to pick the correct answer. So motion means change of speed, automatically you go for kinetic energy. What type of energy is stored when an object is positioned at height above the ground? So height, automatically you go for gravitational potential energy. Next, which form of stored energy is found in battery or food? We mentioned this earlier. So chemical energy. When a spring is compressed or stretched, so this is the spring. When it's compressed during compression or stretching the spring, what type of energy is stored? Automatically you go for elastic potential energy. Okay. When a bicycle lamp is switched on, what is the useful energy change within the battery? So mainly this point it talks about conservation of energy, or how energy can be changed from form to another form. We know inside the battery what type of energy is chemical energy. Chemical energy is stored. So when you turn it on, this chemical energy changes to be light and heat. But the question asks about what is useful energy. So of course heat is not useful energy. So from chemical to light. From chemical to light, we don't have this option. So okay, we don't have light, but we can consider light as a type of electrical energy. So that's why you go for option A. You don't go for D, because from kinetic to heat, kinetic, which is motion, to heat, it's correct, but kinetic is not stored inside the battery. Kinetic, when bicycle starts to move, we're gonna have kinetic energy. This kinetic energy changes to be heat energy due to friction between the wheels and the road, the tires and the road. Which energy transfer takes place when matchstick burns? So mainly originally kind of energy stored is chemical energy. This chemical energy changes to be heat, or we can consider it as thermal energy. So going to pick the answer chemical to thermal. Another example here shows microphone. So this person talks, so sound changes to be electrical energy. So automatically we'll go to option D. Here a child pushes a toy car along a level floor and then lets it go. A car slows down. What is the main energy change? Now, when car started to be pushed, this car will move. Due to friction, will slow down. So mainly energy, since we talk about motion, automatically will be related to kinetic energy. Then it slows down due to friction, which means heat, friction force is responsible for producing heat. So from kinetic to heat. Next part here, it's this part we're gonna use the formula. A car of mass 800 kilograms, so this is the mass, travels over this is the height. By traveling to the top of the hill, the car gains 40,000 joules, so as a potential gravitational potential energy. So this is potential energy, and the gravitational field strength, which is G, is equal to 10. What is we need to calculate height. Something is missed here. These options are gone. Let me check. Okay. So by applying the formula, gravitational potential energy is mgh. طبعا you don't need to memorize any of these formula. Already formula sheet will be provided, so you need just to pick the correct formula based on what given and what the question talks about, what does exactly it talks about. So potential energy is 40,000. What is the mass? 800. The gravitational field strength is 10, and h, straightforward, simple math. So finally we're gonna get that height is 5 meters. This option is missed here later, so it's 5 meters. Going to question 10. A 5 kilogram object is lifted vertically from the ground to the height of, so obviously this is the mass, this is the height. Calculate the change of gravitational potential energy assuming G as 10. Straightforward. So change of gravitational potential energy is mgh. Our mass is 5. You just substitute 10 times 10. Also simple math, it gives 500. You don't forget measuring unit, which is joules. Next, in this question we have here information about gravity. This is the mass, obviously, and of what so calculate the increase in the gravitational potential energy of 12 kilogram of water when it is raised to 3 meters. So obviously this is the height. They haven't mentioned, nothing is mentioned here about G, but we know it's 10. So obviously we need to calculate gravitational potential energy, so straightforward. Gravitational potential energy mgh, straightforward, 12 times 3 times 10, it gives 306. 216 joules. 12 times 3 times 10. 360 joules. I just double checked and I calculated. And so this is the last question related to topic 12. Starting with topic 13, this topic mainly, going back to KPIs, this topic, it talks about conservation of energy. We know that energy is conserved, which means it's not created nor destroyed, just changes from form to another form. So you need to understand the principle of conservation of energy and apply it in different situations. Moreover, you need to use here the flow diagrams to show how energy can be transferred from form to another form. Number 2, you need to understand the principle of conservation of energy and apply the principle in different situations. Finally, use the idea of efficiency to calculate the useful power, the total energy input, or the overall efficiency, which is the percentage. Starting with question 1 here that talks about how energy is able to be changed from form to another form based on different situations. So the diagram shows a man diving into water. Which form of energy is increasing as he falls? First of all, we need to understand at the top here we have 2 types of energy: potential energy, which considered as a maximum value, has its maximum value, and kinetic energy, which is equal to 0 since no motion at the top here. Once the man started to dive into, so this means kinetic energy, potential energy, due to the height, potential energy changes to be kinetic energy. So before reaching the water level here, potential energy is going to be equal to 0 since height decreased, while kinetic energy is going to be maximum. This means potential energy decreases, kinetic energy increases. So which energy, the question asks about which energy is increasing as he falls? Automatically kinetic energy. Next question talks about same concept, same idea. Due to the during the motion, position changes, height changes, so automatically potential energy changes with height or position, as well as kinetic energy. Now at the top here, potential energy is going to be considered maximum because this is at the maximum height, while since no motion, kinetic energy is 0. Due to moving down, while moving down, potential energy decreases because height decreases, kinetic energy increases. Now the question here, a ball is released from rest and rolls down a track from the position shown. What is the furthest position the ball could reach? So the furthest, it would be B, because while moving down, kinetic energy increases. Again, moving up, kinetic energy decreases. So at the maximum point here, it will have no more energy to keep on moving up. That's why the furthest point would be C. Next, I'm sorry, it's I just covered the point. It's not C, I'm sorry, it's B. It is B. C is here. This is B. B. A car is stationary at the top of the hill. Stationary, which means at rest. With energy switched off, with engine switched off. The brakes are released and the car rolls down the hill. At which labeled point does the car have the greatest kinetic energy? So, as we agreed, at the top, potential energy is the greatest, is the highest, has a maximum value, while kinetic energy is 0. Already we have here this is our evidence, because a car is stationary at the top, stationary like at rest. While moving, kinetic energy will start to increase, potential energy, both will be changed due to the speed and the height. So, at which point here kinetic energy will be the greatest? While moving, of course, down, kinetic energy increases, which means that at point C, kinetic energy is going to be the greatest. Going to next point, which is here, this shows changes of position, and automatically when position or height changes, kinetic potential energy changes. Consequently, kinetic energy is going to be changed. So a rubber ball is dropped from a height of 2. This is the maximum height, and some of its energy converted to internal energy. What is the highest possible point the ball could reach after bouncing? So this means it's written here, it dropped from height 2. So this is the starting point. Then it will move down, will bounce back up. The question is, what is the highest possible point the ball could reach after bouncing? So after bouncing back, obviously it will be D, because as we know, if we need to analyze or to understand the situation here, at the beginning, it will be dropped from this point. This means potential energy is going to be maximum. Kinetic energy is 0 because it's still not dropped yet, 0. While moving down, potential energy decreases because height decreases, kinetic energy increases. Then, once it hits the floor, will bounce back. Maximum point will able to reach is D. Next part, this shows pendulum situation. Let's start applying the concept of potential and kinetic energy in a pendulum situation. Now, the diagram shows a ball hanging on a string. The ball swings from point W to point Z. So from W to Z here and back to W again. Which statement is correct? Obviously, here we can notice that when pendulum is swinging between 2 points, there's a change of position, automatically change of potential energy, and kinetic energy is going to be changed as well. So while swinging, going to Z, which is the highest point, this is the highest point, so potential energy is going to be the highest. While passing by this point, which is the lowest point, height decreases, potential energy, height decreases, potential energy decreases. Conversely, kinetic energy increases. Kinetic energy increases. So, which one of these options correct? The kinetic energy of ball is the greatest at point W. Is it correct or no? At point W, at this point, potential energy is the greatest, not kinetic energy, so it's wrong. The kinetic energy of ball is greatest at point X. It's not correct as well because it's greatest at this point, not X. The kinetic energy of ball is greatest at Y. This is correct. So this is the best option to describe the situation.